let's try to solve another Leetcode problem. 2948. Make lexicographically small array by swapping elements. So what is the meaning of lexicographically? So it is just for the numbers. Basically, we're gonna make a smaller number as much as possible. So for example, this is 1, 5, 3, 9, and 8. Basically, we want to get 1, 3, 5, 8, and 9. So this is the meaning of lexicographically smallest array. Yeah, so it is similar like the letters with A, B, C. It's gonna be the lexicographically smallest string. Yeah. So our problem is we are giving an array nums. So for example, we have 1, 5, 3, 9, and 8. And we are also giving a limit, and all those numbers can be reordered. So this means maybe we're gonna sort the array. Because the numbers can be reordered, by sorting an array, we can easily find the distance, because we are going to check the number, the distance, the difference of the number. So for example, 3 minus 1, it is a 2, so it means 1 and 2, it is a group. 3 and 5 is a group, because 5 minus 3, it is also 2, it is less than and equal to the limit. Yeah, as 8 and 9 is also ordered, so it means 8 and 9 are another group, because 8 minus 5, it is 3, it is more than the limit. So we have two groups after sorting. Now, how can we make 1, 3, 5 a group and 8 and 9 in another group? Yeah, because currently you should know that for this number like 1, 3, 5, you should also know the position, I mean the index. So after sorting, the index is gonna be changed. So you need to record the original index. Yeah. So for this one, we have a 1, 3, 5, and this is 8 and 9. And for the index, so what is the index? So for the number 1, the index is 0. For this number 3, so the index is 2. And for number 5, the index is 1. And for the 8 and 9, so the index is 4 and 3. Yeah. So in our group, but we are not going to store the values, the numbers. We are going to store the index in our group. So for group index 1, 0, 1, 2, it is a group, and for another group with index 3 and 4. So this means before we are sorting this array, we're gonna store the original array. So we're gonna prepare an original array. It's gonna be a copy of the nums. Yeah, so we're gonna copy of the nums first, and then we're gonna sort the nums, because after sorting, we're gonna connect them. After sorting, we can connect them easily, like 1, 3, 3, 5, 8, and 9. We can connect them easily. So now, inside the index, 0, 1, 2 is a group, 3 and 4 is another group. But we can use this index to get the values. Because we know from the original array, the index 1, it is the number 5. The index 2, it is the number of 3. So in this way, so for example, we're gonna sort the index like 0, 1, and 2 at the same time, and we're gonna sort the numbers. So the numbers are gonna be 1, 3, and 5. Yeah. Now we're gonna put all the numbers inside this index. 1 to this position, 3 to this position, 5 to this position. So this means one of the group has already been finished. So similarly for this 8 and 9. Yeah. So currently the problem comes to us is that how can we connect 1, 3, and 5? Even we find it is in a group, 8 and 9 in another group, how can we find that? We can use unified to make it a group. Yeah, definitely we can use unified to check. If the distance is 2, we're gonna use unified to connect. But we're gonna connect the index. So it means the index 0 and the index 2 gonna be connected. And for this for 3 and 5, it means 1 and 2 gonna be connected. Yeah, so the index 1 and 2 gonna be connected. So in this component, this is a connected component. This means index 0, 1, 2 is connected. Now we've already found the group, and then we can just check the answers. Yeah. Now let's try to solve the problem. Because we are going to use unified, so I prefer to copy the unified template. So basically, let me find a template. So we just need to copy this template for our code, and you can Yeah, I mean after this video, I'm gonna post this template, and maybe you're gonna use. Maybe you already have the template. You just need to copy it, and then directly gonna use it. Yeah, just for saving the time. Otherwise, I need to take a lot of time to write this template. Basically, there's no meaning if you are really familiar with what is unified and how can you write this kind of template. Yeah, but for our problem, we're gonna focus to solving the problem instead of how to write a template of unified. Yeah. So for us, let's just prepare this unified. I'm gonna use a number. A variable n, so this n gonna be the length of the nums, because I'm gonna use the index as the node of the unified. It means from index 0 to n minus 1, so that's gonna be put inside of my unified. So basically this is n, and I put it inside, and I'll build a unified structure. So it means the length of the nums is 10 to the power of 5. So this means we can use unified to solve the problem. Basically, the time complexity is gonna be n log n. Yeah, but let's just try to solve it step by step. So I'm gonna prepare an index original array. So I'm gonna use origin. It's gonna be the nums copy. This is because I'm gonna sort the nums later. So I'm gonna sort the nums. So I need to have the origin of the nums, because inside of this nums later on I'm gonna use the index to find the original value. Otherwise I cannot find it. So currently this nums has been sorted. So I'm gonna get an increasing order of this nums, and I'm gonna use it to check the distance. So the difference, if it is less than and equal to 2, and basically I can connect them. Yeah. And for the index array, I'm gonna put an index array as a hash table. This hash table gonna record the position of the index, because later on, after sorting, the index gonna be changed. I need to record the original position of my index. Yeah, there may be other ways. Yeah, but you can also try other ways like hash table. It's the same idea. So I'm gonna use the list return with the index, and the index also should be sorted according to the numbers in increasing order, but I just need to record the index. So this is my index, and this is my nums index with this number. So this means the number gonna be sorted, and also my position of the index has been recorded. Yeah, because later on I'm gonna use the original index. Now I'm going to check the nums one by one, but I'm gonna start from the second one, because I'm going to check the difference. Yeah. So for I in read n, I'm gonna check it. So if nums I minus nums I minus 1, if it is less than or equal to the limit, so this means we can connect them. Yeah. But we can also have another check, because in my structure, basically I need to check if not uf dot is connected. If that two nodes is not connected, I gonna connect them. Yeah, but it is also okay. It depended on your template. Normally, yeah, you can also ignore this line. Yeah, but this is just for saving some time. So if it is already connected, I will not do that. Only if it is not connected, I will connect it. Yeah, so this is just for saving some time. Inside there are gonna be two values, but I gonna write it later. Now the uf gonna union, I gonna union them together. So it's gonna be the two index. Yeah, but currently after sorting, the nums position has already been changed. But I need to record the original position of the index. So I'm gonna use this hash table, index hash array, with this I and an index with I minus 1. Basically, I'm gonna connect the two index. For example, number 1 and 3. I'm gonna connect the index with 0 and 2. Now our unified function basically has already been finished. We just need to check what is the result. Let's just check what is inside the unified, if the element is connected or not. Let's just have a check. Yeah, so now we're gonna use a default dict. I'm gonna prepare a list because I want to know what is the connected component, what is the connected index. Yeah, so I'm going to check all the index. So for I in array n, so I'm gonna use the d with the uf.find. I'm gonna find all its parent, because if it's connected, all those components 1, 2, 3, all those components would have a single parent. I want to find this parent. So this uf.find, I'm gonna find the parent with I, and I'm gonna append it inside a list. So I'm gonna append I. Yeah. Now let's just have a tag what is inside this dictionary, and let me return an empty array. Yeah, there's something wrong. Yeah, because I forgot to put those two indexes inside the not connected. Yeah. Now let's just have a tag before making any mistakes. Yeah, now you can see it seems right. So this is the parent that is okay, but for the index 0, 1, 2, it's a group. It means 0, 1, 2 connected. 3 and 4 also connected. It means okay. 8 and 9 connected. 1, 5, 3 also connected. Yeah. Now our problem should become easier. We just need to check the result. Yeah. So I'm gonna prepare a result array. It's gonna be 0 times n. And finally, I'm gonna return this is right result array. But before that, I need to check the positions. Yeah. So I'm gonna use an array for array in d.values, because basically I just need to check all those values. Yeah. And let's just use index and value inside a zip. I'm gonna use the sorted index and sorted values, because I think this kind of writing may be easier. Yeah, maybe you have some others, because in Python definitely you can use a lot of Pythonic ways to solve the problem. Yeah, but I'm gonna use the sorted the index first. So inside the zip, the first of all, so this array is just an index array. So I'm gonna sort the array. It means all those index gonna be sorted. Yeah, and also I'm gonna sort the values. So the sorted is going to be inside the values. So what is the values? Because I have this arisen array, definitely I can use it to check the values. So it means the arisen I, this is the index. So for I inside the array. Now inside the array, I also get the values, and I'm going to zip them together. I'm going to check the index and value. And for this index and value, I'm going to directly put it inside the result. So the result I, this is my index and this is my value, and finally I'm gonna directly return the result. Let me just check if everything is okay. Yeah, it seems there's something wrong with it. For this one is okay, and for the second one it is not okay. Yeah, because maybe I didn't use this limit. I used some numbers too. I used the limit. It is okay. 167 to, yeah, normally it should be 167 and 18, 1 and 2. Yeah, because this is a group, it can be changed, and this is another group, it can be changed. Yeah, let me just check the reason. Normally I solved it, I didn't make any mistake, but this time I make a mistake. I have to check the reason why. So if they are not connected, yeah, let me just check this example. Check what is inside of the dictionary. Maybe I made some silly mistake. I cannot even find it. Yeah, I want to print out the dictionary to check if my union file is okay or not. Let's just check this one. 0, this is 0, 1, 2, it is okay. This is 3, 3 and 4. For 5, this is 5. This 3 and 4 connected. 5 is another one. This means it is not okay. So for index 0, 1, 2, 3 should be a single one, and 4 and 5 should be connected. Yeah, let me just check the reason. So for this index array, maybe it's just because of the index array. If the value of nums is less than the limit, and the index of them are not connected, I will union the index. Yeah, let me print out the index to check what is wrong with it. So the index is so after sorting, the index is the same. Let me check. The index should not be the same. This is just 0 to 5. This means something wrong with my index hash array, hash table. Yeah, normally after sorting, the index should be changed. So index.sort, and this is my index, and this is nums. Yeah, this is why, I believe, because I used it here. Maybe I needed to put those two lines above that, because if nums already be sorted, there's no meaning to do that, because if I were to record the original position of the index, I have to record it before the sort. Yeah, so this is the mistake, I believe. Yeah, now let me just run it to check if it is okay. Yeah, now it seems it is okay. Let me just delete the printer and try to submit it to check if everything is okay. Yeah. At the same time, let's analyze the time complexity. Because this is just unified, we're gonna analyze it as log n or O1. It is okay. As you can see, it passed. Although it is less than 1 second, it is a little bit slower, but I think it is still okay, because unified, definitely it is very slow. And the time complexity, it is n log n. As you can see, here is sorting, this is n log n. And from here, you use the unified. Basically, you can say it as n log n, or you can say it as O1, because this unified, if we optimize it like the racking and path compression, basically it's going to be O1. But there is the nums sort anyway, so the time complexity is going to be n log n. Thank you for watching. See you next time.